Today, we're tackling a really fundamental challenge in the world of containers. How do you save your data when everything is designed to be temporary? Okay, let's start with a scenario that, well, every developer dreads. Imagine this. You've got a database running, your app is writing all this critical information to it, and then, poof, the container just vanishes. It crashes. So, is that data gone forever? This question really gets to the heart of what we're talking about today. Because, by default, without the right strategy in place, the answer is a big, scary yes. See, at its very core, Docker is built on this really powerful idea of, well, ephemerality. Containers are meant to be transient, disposable, totally interchangeable. You spin one up, you tear it down, no big deal. And that's absolutely fantastic for what we call stateless applications. But it creates a huge problem for anything that actually needs to remember stuff. So what's happening under the hood? Well, when a container writes data, it's doing it in this temporary writable layer that sits on top of the base image. And this system has some serious downsides for data you want to keep. It can be slower, it's a real pain to access for things like backups, and, this is the big one, its entire life is tied directly to the container. The moment you run Docker RM, poof, that writable layer and all your precious data is just gone. Forever. So, how do we fix this? I mean, there has to be a way, right? Of course there is. Thankfully, Docker doesn't just leave us high and dry. It gives us a few really key tools to bridge that exact gap, the one between these temporary containers and the permanent data they need to function. Okay, so here are your options. You've got volumes, you've got bind mounts, and there's also something called a tmpfs mount, which is just for temporary in-memory stuff. We're going to focus on the first two, volumes and bind mounts, because they're the main tools for permanent storage, and you'll see they have completely different philosophies behind them. All right, let's get into it. The big decision you'll be making over and over again is, do I use a volume or do I use a bind mount? And trust me, understanding the difference here is absolutely crucial if you want to build solid production-ready apps. So let's break down this difference in control because it's huge. Think of a volume as a first-class citizen in the Docker world. Docker itself manages it, where it lives, its life cycle, its security, the whole shebang. It's like a managed safety deposit box. A bind mount, on the other hand, it's just a direct doorway. It maps a folder inside your container directly to a specific folder on your host machine. The container gets full access, sure, but now it's completely tied to that specific machine's file structure. And this table just spells it all out, doesn't it? For production, volumes are the clear winner, no question. They're portable, they're way more secure, and they actually perform better, especially on Mac and Windows because they don't have that annoying file syncing overhead that plagues bind mounts. Now, that's not to say bind mounts are useless. They are incredibly helpful for local development. When you're editing code on your laptop and want to see the changes show up inside the container instantly, that's the perfect job for a bind mount.
Okay, so you've made the wise choice. You're going with volumes for your production workloads. Excellent. That's the professional standard. Now, let's actually walk through how you manage these things, their entire life cycle, so you can keep your system clean and organized.
It really just boils down to these 4 basic steps. You create it, you use it by attaching it to a container, you can inspect it to see what's going on, and, super important, you clean it up when you're done. Now, when you go to attach a volume, you've got 2 ways to do it. There's the classic V flag. It's short, it's sweet, but it has this really dangerous little quirk. If you make a typo in the volume name, it might not fail. It might just create a random new folder on your machine. The modern mount syntax, on the other hand, yeah, it's a bit more typing, but it is so much safer. It's explicit. You spell out the type, the source, the destination, and if that source volume doesn't exist, it'll just fail, loudly, which is exactly what you want. And that is exactly why it's the recommended best practice today. That fail-fast behavior, it's an absolute lifesaver, especially in your automated scripts and CI/CD pipelines. A silent error there could be catastrophic, but -mount helps you avoid it completely. Okay, so over time, as you're creating and destroying containers, you're going to end up with a bunch of unused volumes. It's just inevitable. Some are named ones you created, others might be anonymous ones Docker made for you. But once they're not attached to any container, we call them dangling volumes. And they just sit there, quietly eating up your disk space. So finding them and cleaning them out is a super important bit of regular maintenance. The good news is, Docker makes this pretty easy. You can list all the dangling volumes with a simple filter. Then, Docker Volume Prune will get rid of all the anonymous ones for you. It'll even ask for confirmation first, which is nice. But And this is a huge but. Be extremely, extremely careful with the -all or -a flag. That thing will wipe out every single unused volume, including the named ones you might have been planning to use again. And there is no undo button. Seriously, use that one with caution.
All right, let's get to the good stuff. We're going to wrap up with some pro tips for managing your data that will really take your Docker game to the next level. So here's something you might find surprising. Docker doesn't actually have a command like Docker volume backup. So what do? Well, the standard practice that's evolved in the community is to use something called a sidecar container. It's basically a temporary container whose only job is to do the backup for you. And the process is actually pretty clever. Here's how it works. You spin up a temporary, short-lived container, maybe something super lightweight like Alpine Linux. You then mount two different things into it. First, the actual data volume you want to back up. Second, a directory from your host machine where you want to save the backup file. And then from inside that temporary container, you just run a command like tar to archive everything from the volume into that backup directory. Simple, right? Okay, now for a super important warning. That sidecar method is awesome for regular files, but it is absolutely dangerous for live databases. Why? Because just copying the raw database files while it's running can give you a corrupted, inconsistent mess. So for any database, Postgres, MySQL, whatever, you have to use its own native backup tools, like pgdump or MySQL dump. And you usually do that by running the command inside the live database container using docker exec. That's the only way to guarantee you get a safe, reliable snapshot of your data. All right, let's talk about a common pitfall, something that causes a lot of confusion and headaches for people. I'm talking about the volume instruction that you can put right inside your Docker file. Here's the deal. Most experts today will tell you flat out, just don't use it. It's kind of a relic from Docker's early days. It causes problems, like silently creating these anonymous volumes that are a pain to track and clean up. Even worse, it effectively locks that directory, meaning anyone who tries to build on top of your image can't add or change files in that spot. So what's the best practice now? It's way simpler. Just document the mount points your application needs in your README file. That's it. Okay, let's bring it all home. Here are the key things to remember from this whole explainer. First, containers are disposable, but your data is not, so you have to plan for that. For production, that means always using Docker volumes. They're portable, secure, and managed by Docker itself. Next, always use the safer, more explicit mount flag to avoid nasty surprises. Get comfortable with the whole volume lifecycle. Create, use, inspect, and then regularly prune the old ones you don't need anymore. And finally, have a solid backup plan, especially for databases, using a sidecar container and their native tools. And all of this leaves us with one last big question. The magic of Docker is all about its temporary, ephemeral nature. But that very nature forces us to be incredibly deliberate and thoughtful about the data that has to stick around. So the question I'll leave you with is this. Are your containers ephemeral? Yes. But is your data strategy built to last?